Hi everyone, welcome back to these lessons on rivers. Again, rivers is a topic that people tend to really struggle with. So my advice, especially in this lesson, would be to watch this a couple of times, pause it at certain times, make some really good notes, and attempt any practice questions that you see. Okay, so what we're going to look at today is the causes of flooding, and these can be categorized into human and physical causes. And then we're going to look at what I would say is quite a tricky concept, and that's the idea of a flood hydrograph. So these are the different human and physical causes of flooding. So you could pause it at this stage and try and work out what they are. The top three are the human causes and the bottom three are the physical ones. Okay, if you did pause it, then hopefully you've acknowledged that this is urbanization, this is deforestation, and this is agriculture. This is heavy rainfall or precipitation, this is geology, and this is all to do with the relief of the land. So I'm going to go through each one of these now, and there they are. So in order to understand the different causes of flooding and to be able to put it into a written answer, there's some concepts that kind of come up in most of these, and I call this like my winning formula. So if you can learn these sort of keywords, then you can kind of apply most of these to pretty much all of the causes of flooding. So I'm just going to go through each of these with you now. So surface runoff, in theory, is just water running along a surface. Okay, so it's water flowing over the land's surface, and it does this when the ground is frozen, or it's already saturated, or it lands on an impermeable surface like hard rock, or an urban area like tarmac. Impermeable just means that water cannot infiltrate. I think of impermeable as impossible. Okay, so it's impossible for water to be absorbed into it. So you can have permeable surfaces which can absorb water, like soil and clay, or you can have really hard rock, again, or tarmac, which is more impermeable. Saturated soil kind of just talks for itself. It's just literally where the ground is saturated. And like we said earlier, that can lead to increased surface runoff. Infiltration is just a posh word for soaking up or water being absorbed into the ground. And interception, think of it as if you were intercepting a pass in netball or football. It's where the water gets kind of blocked, there's the word blocking, by vegetation like plants and trees and things like that. And again, that can have an impact on reducing flood risk. So let's get into each one of these in a bit more detail then. So the first one I'm going to look at is this idea of urbanization. So I've kind of put in bold all of the keywords that you need to know here, but there's a really good picture which kind of shows this happening. And so all you have is rainwater lands on an impermeable surface like tarmac, where it cannot infiltrate, and this just increases surface runoff back to the drains or the river or the stream, and eventually that river will obviously burst its banks because water is getting into it really super quickly. The next human cause is similar, but it's linked to deforestation. So we said earlier that trees and plants can intercept water, which means they can block the water and absorb it, which means less water hits the ground. So if you remove that vegetation through deforestation, that rainwater is going to hit the ground quicker, which means that soil is going to become saturated. And we said earlier, didn't we, that if the ground is saturated, it can't absorb or infiltrate any more water. So that's going to increase surface runoff. And again, that water goes back into the river, causing the river to burst its banks. And I think this picture shows it really nicely. If all those trees were still there and the branches and the leaves would be able to intercept that water and stop it hitting the ground. And some of that water would then be evapotranspirated back into the atmosphere. But it's not there, so it can't. So it's just hitting the soil, becoming saturated, and that in itself is a flood, but also that water is going to run off into the nearest stream or river. And then agriculture is really, really similar to deforestation. So before we talked about deforestation is when you cut down trees. Well, agriculture is exactly the same. You know, these fields were once woodland areas. So when you remove that vegetation, again, there's going to be less interception. The soil becomes more saturated, and that increases surface runoff. We're just playing a game here. We're saying the same things over and over again. We're just tweaking them ever so slightly. This is made worse during harvest, because any crops that were there that could absorb the water have now been removed. So it leaves that bare soil. So the rainwater cannot be infiltrated, so it runs into the nearest stream or river, and that can cause it to burst its banks. The one thing I would add to this, it's quite hard to see, I'll just put it there. when you've got sediment on top of this sort of agricultural area, that topsoil and sediment is also going to run off with the water, and that's going to therefore go into a river, and then it's going to land on the riverbed, and that's going to build up over time, which means the river can't hold as much water because it's become shallower, which you would word this as it reduces its carrying capacity. In theory, that river is going to burst its banks quicker because it's been made shallower by that runoff that's gone into the stream or the river nearby. Hopefully that helps. I can't move my face. Where am I? There we go. Okay, so let's talk about heavy rainfall. A couple of different options here. You could literally just say that the rain falls straight into a river. And again, therefore, the river will burst its banks, but that's quite weak. There's not a lot you can really say about that. So you could go back to this idea of rainwater hitting that saturated ground, making it even more saturated, so therefore it becomes impermeable. Great picture here showing this, okay? No way is any rainwater going to infiltrate here because it's become impermeable because the ground is already saturated. Think of a wet sponge. When it's dry, you pour water on it, it can absorb it. If it was soaking wet and couldn't hold any more water, when the water does hit it, it's just going to run off, isn't it? Okay, try that next time you have a shower or a bath. So that increases surface runoff to the river, and the river will burst its banks. Let's play that game again. And then we have geology, which is exactly the same as urbanization. But this time, instead of landing on tarmac, okay, or buildings, it's landing on hard rock such as granite. And again, I'm not going to get you to explain it, but if you were, you would just say, therefore, the rainwater lands on impermeable rock, and then we have surface runoff into the river or the stream, causing the river to burst its banks. And then the final one is this idea of relief. Okay, if you're not sure what the word relief means, think of it as the height and shape of the land. If you were to climb a big mountain, you get to the top and go, oh, what a relief. Okay, and also relief rainfall is when warm air is forced to rise above mountains, cool and condense. You can see that happening here. So that's going to give us relief rainfall or snowfall. So two different explanations here. You can talk about really steep ground. Imagine you lived at the bottom of this valley here. Boscastle in Cornwall flooded, I think it was 2004. Because of this happening, the rain is going to run off down the steep sides really quickly. And again, that's going to get into the river and cause it to burst its banks. The opposite of that is really flat gradient. So the Somerset Levels, which flooded in 2014, that's because the ground is so super flat, so it can't run off. It's almost the complete opposite. So it just sits there. The ground becomes more and more saturated. The water under gravity can't go anywhere, can't go back into the river, it can't escape. So it's just going to sit there, and that in itself is a flood, isn't it? If the water just sits there, it is a flood. So that's how relief, whether it's steep or flat, can impact flood risk. Okay. So just a little EdXLB taster there. Evaluate the role of physical and human processes in causing flooding. So you just had a look at 6 different causes there. So I would personally do a paragraph on physical, a paragraph on the human ones, and I'd be using P structure: point, evidence, explain, evaluate. And with that, you're weighing up what do you think is the biggest factor that causes flooding. Maybe that's your conclusion. Do you think it's human factors? And do you think it's physical ones? And each paragraph, you could discuss potentially 2 human ones in each paragraph. Sorry, first paragraph, then 2 physical ones, and weigh up within the paragraph as well. So out of urbanization, deforestation, and agriculture, rank them now 1 to 3. What do you think is the biggest cause of flooding and why? And that could be your first paragraph. I think the most significant human cause of flooding is because, and therefore, and this is a bigger cause than this because. Really, really strong paragraph. And then do the same for physical. Talk about geology, relief, or heavy precipitation. And then your conclusion would be weighing all of that up and saying which is the biggest cause in your opinion and why. Does it have more of an impact in the short term or the long term? Okay. And, that's when we start talking about real evaluation, those AO3 themes. Okay. Hydrographs. Ugh. Okay, so a couple of phrases you need to be aware of straight away. Discharge is just the amount of water that's flowing in a river at a given time. It's measured in cumex, which stands for cubic meters per second. You can break it down. Cubic meters, X are the seconds, okay? Cubic meters per second. So imagine a big cube. I think I use my desk at work, like a big cube. And it's how many of those are flowing every second. And that's this line here, okay? This is rainfall. These are bars. So the rainfall bars, a bit like a normal climate graph. And there's the axes there. So here, when you've got your peak rainfall, you can go across to here and it's like 50 millimeters. All right. Your discharge, your peak discharge, which is the most amount of water flowing in that river at a time. Again, it happens at this time. And you would say it's like 50 cumecs or just over, which is 50 cubic meters. You can't even imagine how much water that is. 50 cubic tables worth of water going through every single second. So a phrase you need to be aware of is lag time, which is the time it takes between peak rainfall and peak discharge. Now, this particular hydrograph has it in days. So you would say on day 1, the rain started here. And then halfway through the day, we had peak rainfall at 50 millimeters. So let's just say that's something like, 12 o'clock lunchtime. And then day 2, your peak discharge, a bit later in the day, maybe 3 o'clock in the afternoon. So therefore, that's taken 27 hours. What does that mean? The lag time is 27 hours. So it's taken 27 hours for peak rainfall, the rain falling at its absolute highest and fastest and most, to when the river's flowing at its fastest. And you can see that looks like quite a short amount of time. And now we know that because the rising limb is really steep, which means the water's getting in the river really, really quickly. That's not good. That means this river is likely to flood. Okay, because the water's getting in the river really quick, so it's building up, bam, it's going to burst its banks, it's going to lead to a flood. Now, you've also got this falling limb here, which is quite steep. That's quite a good thing, because that also means the water is leaving the river quite quickly as well, flowing downstream. So that's not bad. It'd be worse if it literally did this and flattened right out. Then we're in serious trouble. But as it stands, this is still a pretty scary, like flash hydrograph. This is going to be a flood. So what you need to think about is, what are the things that can reduce that lag time? So what are the things that can make this even shorter? And then you can link that to the causes of flooding. So what sort of things have we looked at that might make it quicker for the rainwater to get into the river? Have a little think. Okay. And if you said things like this, then you're right. So steep ground. If it's really, really steep, it's going to get in the river quicker. Therefore, it might burst its banks quicker. If you talked about urbanization, the fact that we've got tarmac and it's impermeable. So again, it's going to land on that hard surface and run into the river really quickly. It could be geology. It could be hard rock nearby. It could be agriculture. This could be a farm. This could be an area that's had some deforestation. So these are all the things that can shorten the lag time and increase flood risk. And then you can do the opposite. What might slow it down? So flat gradient, if it's really flat, it's not going to get into the river too quickly. If there's lots of vegetation around, or if there's soft rock absorbing that water, it's going to slow it down. Okay, so this is how we can link the causes of flooding to hydrographs. And just to show you what a question might look like here, study figure 14, flood hydrographs for 2 different streams after the same storm. Differences in the shape of flood hydrographs are caused by both human and physical factors. Do you agree? Use figure 14 and your own understanding to explain your answer. So at this stage, pause it, give it a go. Okay, this is a 6-mark question. So think how many paragraphs, how you're going to categorize those 2 paragraphs, what you're going to put into it. Pause it now, give it a go. Okay, and I'm going to tell you what you should have done, and hopefully you've got something along these lines. So absolutely, the differences in the flood hydrographs are caused by both human and physical factors. So I would be doing a paragraph on human factors first of all, because that's what it says there. So I would say, yes, I do agree that the change or the shape or differences in the shape of flood hydrographs are caused by both human and physical factors. I agree to great extent, you might say, which means you really agree. And then I would say an example of a human factor would be urbanization. And then I've got to choose which figure I want to talk about. So which of these do you think might be an urban area? And if you've got it right, it would be Austwit-Beck, potentially. Google it. I can't remember. I'm not too sure. But just from the shape of this discharge line, the rainfall is the same. Remember, it's the same storm. But look at this steep rising limb and actually look at the lag time. You can work out the lag time here. Peak rainfall is at 2 o'clock or 2 hours into the storm. Peak discharge is 8 hours in. So the lag time is 6 hours. So that means it's only taken 6 hours from it raining at its heaviest to getting in the river flowing at its absolute peak discharge. So that means it's probably an urban area because that rain has hit that impermeable surface and flowing into the river really quickly. It could also be due to agriculture. This could be a farmed area or somewhere that's experienced deforestation. So if I was putting this into a paragraph, I would say something like, I agree to great extent that the differences in shape flood hydrographs are caused by both human and physical factors, and this is because when we look at figure 14, it shows that Ostwit-Beck has a much shorter lag time of just 6 hours. This is likely to be because it is an urban area, which means rain hits the impermeable surface, flows over that surface into the nearest stream or river. This therefore speeds up the lag time and is just one example of how human factors can shape flood hydrographs. That's right. Okay. And then I would do the same for physical factors. And I would say, however, physical factors also play a part. For example, geology, or for example, the relief of the land. Clapham Beck is likely to be a flatter area. I know this because the lag time is actually, so we've gone from 2 to 20, 18 hours. Okay, 18 hours, much, much slower. So this is likely to have a flatter gradient. Potentially it's got some soft permeable rock like clay, which is slowing down that rainwater getting into the river and therefore increasing the lag time. Okay, so that's how I would tackle that. One paragraph on physical, one on human, and notice how I referred to the figure constantly. I hope that's been useful. That's some really challenging stuff in there. Well done if you gave those questions a go. And I'll see you next session for our last rivers lesson.